So hello guys, for today's video, I'm gonna explain to you the implementation of brute force algorithm which generates and prints all possible pin combinations of a given length and calculates the time it takes to do so. I will explain each functions and how program works step by step, including computing the running time. So firstly, this line of code imports itertools module. So this import statement provides tools for working with iterators and generating combinations or permutations, same as the import time module, which allows you to work with time-related functions. So we come now to this function, which generate pin combination. So this function that generates all possible pin combinations of a given length specified by the combinations parameter. It uses the itertools product functions to generate the combinations and returns them to a list of string. So this print pins combinations generated pin combinations and calculates the execution time. Inside pins, it starts measuring the execution time by recording the current time using this, which is time.time, in the start time variable. It then calls the generated pin function to generate the pins for the specified combinations and stores them in a pins list. So move on now to these functions, num combinations. These functions prints all pin combinations one by one and also display the total number of combinations, time complexity, and as well as the time execution. So we come now to this function. So this line takes users input to specify the desired length of the pin. It then converts the input to an integer and stores in a combination variable. So lastly, these functions cover the if-else statement. So this is to check whether if the input not within within the valid range, then it calls the print pins functions to generate and print the pins. Else, it prints an error message indicating that the pin length is invalid. So now I'm gonna show to you how this program works. Let's try to run this program. So as you can see here, there is a user input where asking to enter your desired pin length range from 1 to 10 only. So let's input 2. So as you can see, here, it displays all 2-digit pin combination which starts with 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and so on so forth. It ends with 99. So the number of combination is this 100. Then the time complexity is O100. So why is this O100? Because the time complexity of this code is O10 raised to n, where n is the where n is the length of the pin. This is because for each digit positions in the pin, there are 10 possibilities from 0 to 9, and since the pin has n positions, the total number of combinations is 10 raised to n. So the execution time is 0.0066 seconds. So next, let's try to enter 3 as a pin length. So as you can see, these are all the 3-digit combinations. Combination is 1000 and the time complexity is 1000 and the time execution is 0.0015 seconds. So let's also try to enter 4. So we enter 4 as a desired pin length. So as you can see, this program generated and print all 4-digit pin combination and display the number of combination, which is 10,000. And the time complexity is also 10,000 and the execution time is 0.003469 seconds. So let's also try to input 5. So we input 5 as a desired pin length. So this is all the generated 5-digit pin combinations. So the number of combinations of this 5-digit pin combination is 100,000, as well as the time complexity, and the time execution of this is 0.013038 seconds. So lastly, let's also try to input 6. So we input 6 as the desired pin length. So in this case, when you input 6 as the desired pin length, the program will generate and print all 6-digit pin combinations. So the number of combinations of these 6-digit pin combinations is 1 million, as well as the time complexity. And the time execution in seconds will depend on processing power of the computer, but will be proportional to the number of combinations. So generating and printing 1 million combinations may take a significant amount of time. So let's end here, and I hope you learned something from this tutorial.